So good evening, friends. We are starting a short tutorial on how to set the relays in a given power system. Today we will see only phase over current relays. When I say phase over current relays means there are two kinds of relays. One is a phase over current relay that is mounted on R, Y and B phases. And the second kind is ground over current relays, which are to be used for ground faults. The setting philosophy for both the kinds of relays are altogether different, and we cannot talk both the things together. In today's short tutorial of around 15-20 minutes, we will be talking only about phase over current relays and not the ground over current relays. So how the relays are to be set when it's a series of different relays, how to coordinate different relays. And we will start with a very simple radial system because we cannot immediately go to a complicated system. Slowly we will enter into complications also as we go to further tutorials. But today we will restrict ourselves to a very simple radial system. Radial system means a system which is fed from only one side, source is only at one side, at the other side there is a load. So friends, this is our simple system. This is our simple system. We have got three generators, as you can see on left side. 15.75 kV, 210 megawatt, right? And they are connected to GTs, generator transformers, 15.75 kV to 220 kV to 50 MVA. All these three generators are connected to bus A, 220 kV bus A. From bus A, there are many lines emanating, many 220 kV lines emanating. One of the lines is leading me to bus B. On that line, I have a CT 1000 bar 1 and a relay connected R1. I would remind once again that R1 is not a single relay. R1 is a group of relays. There are three relays, R, Y, and B, and one ground relay. That is, it's a system of four relays, right? So that is R1. And we are going to talk about only phase over current relays. That is on RYB. From bus B, the power obviously has reduced, and the distance also might have reduced. Therefore, the economic voltage is different, right? Economic voltage is now not 220 kV, it is 132 kV. So we are transmitting power at 132 kV now, right? And then we come to bus C. There are relays R2 and R3. Between relay R2 and R3, there is a transformer that has to be remembered, because you see, while we will be calculating the current, that transformation ratio will be there. Then if you see from bus C, once again, there are many 132 kV lines emanating. One of the lines, 132 kV line, is coming to bus D. From bus D, once again, now the economic choice of voltage is 66 kV. So we come to 66 kV. And from 66 kV, that is coming to bus E, and from bus E, many 66 kV lines are going. One of the line is terminating on 66 by 11 kV distribution substation. This is our simple radial system. What all we want to do is we want to find out plug setting and time multiplier setting of R1 to R7. We do not want to go very fast, because you see, if you talk about the numerical relays, then the setting philosophies, the way of calculations are different. You see, there are many kinds of settings. Some 17 different kinds of settings are there if we use numerical relays. Right? We had been talking in two first tutorials about numerical relays, and in time to come we will talk about how to decide the settings, or how to configure the numerical relays also. That's what we would want to see slowly. But right now, let us concentrate only on two settings, flux setting and time multiplier setting, right? The third setting can be the setting of instantaneous high set unit. That also probably we will do only for one relay, to give an example, just to give an example. Because otherwise, you see, if we add instantaneous overcurrent unit to all relays, then the TMS will be different, because the relays operate faster if we going for instantaneous unit for all the relays. So right now we don't complicate everything. We just want to initiate the discussion on setting of overcurrent relays. So for this, what is the data given? You can see what is data given is the first line 220 kV line is taking 197 megawatt. That is given to me at 0.8 PF. Another line 132 kV line 66 megawatt, and third line 66 kV line is taken 22. So 197. First line 220 kV, second line 132 kV, some 66 megawatt, and third line 66 kV line, some 22 megawatt. That is the full maximum rated power flowing through the lines, and that power considers 10% overload. That's what we assume. So we have not to multiply by 10%, that 1.1 factor. We may forget, because you see that we would want to go fast. So this is one thing that I'm given to. I'm given. The second data that is given is fault data, because for calculation of TMS, time multiplier setting, I'll need fault currents. So fault currents are calculated and are given readily on buses A, B, C, D, and D. Triple line fault and double line fault amperes are, I think you can very easily see these things, right? So that is given to me. So now, based on this, I have to start calculating the plug setting. First, plug setting means I have to start from last relay, very obviously R7, and because I'll be going towards source. R6 is going to back up R7, R5 is going to back up R6, R4 is going to back up R5, and so on. Obviously, the very big disadvantage of this overcurrent relays is R1 will have highest TMS. The fault near the source, which is the worst, is going to be cleared very slow. That is the problem of overcurrent relays, and therefore we go to distance protection and line differential relays. But let it on one side right now, because we cannot jump to many things at a time. Right now, let us, no doubt there is it's not so that there is no remedy to that. You can attach high-set instantaneous unit to relays to make them faster. You see, that is also quite possible. But instantaneous unit cannot be attached everywhere. That is also a problem. If a line is too short, you cannot attach an instantaneous unit. So there are many problems in overcurrent relays, no doubt, right? But right now, let us not talk about problems and everything. Let us concentrate on how to calculate. So we start with the last relay, R7, obviously. So R7 obviously depends on the full load current, because phase relay means to RY and B, full rated current is going to pass. If it is ground relay, it is going to be different. But now when we are talking about phase relay, normal current is going to pass, and your setting has to be higher than the full load normal current. That is very obvious, right? One thing. Second thing, what you have to do when you are thinking of coordinating it, let's say R6 and R7, then R6 will give backup to R7. And when I'm talking of backup, I have to consider that coordination. Coordination means the pickup, at what value the relays pick up. Now pickup as per the standard varies from 105 to 130% of plug setting. Right. Therefore, when I consider the plug setting of R6, it is going to be 1.3 divided by 1.05 times that of R7. So that 1.3 by 1.05 factor will come when I'm talking about two coordinating relays. When I think of plug setting, these two things I have to keep in mind. Which two things? First, the normal rated current. Second, that 1.3 divided by 1.05 factor. Second, third thing which I should consider is that any relay, say relay R4, must reach up to bus E, the next bus, because it has to give backup to R5. Similarly, relay R2 must reach up to D because it has to give backup to R4. Must reach means for the minimum fault current it must reach. These three things we have to keep in mind. Considering that I start with R7, my dear friends. R7, you can see it depends on rated current of 66 kV line, which is given to be 22 megawatts. 22 megawatts, if you calculate 22 into 10 raised to 3 divided by root 3 to 66 and 0.8, all these things well known, right? 0.8 is power factor. 66 is kV, 22 is megawatt. So I'm coming to 240.56 ampere, and 240.56 ampere as a percentage of 300, because R7 is mounted on 300 bar 1 CT. 240.56 as a percentage of 300 is 80.18 percentage. Had it been numerical relay, I would have been able to go to 81%. But right now I do not go to that. I do not jump to that. I think of normal, our conventional relays in which our setting range is 50 to 200% in steps of 25%. So next availability from 80.18 is only 100. So my plug setting of R7 is 100% done. Now for R6, what I have to do? For R6, my dear friend, I have to consider R6 means it is taking the full load current of 132 kV line as seen on 66 kV side. That is very obvious. No doubt, R6, R7 coordination also I have to consider. So if I consider that, my dear friends, how do I decide the plug setting of R6? Based on 66 megawatt, that is on 132 kV line, my current comes to 721.68 ampere, and that 721.68 ampere as a percentage of 1000, because R6 is 1000 bar 1 CT. As a percentage of 1000, it comes to 72.16%. So my plug setting of R6 in next 25% step is 75% done. Let me check up coordination between R6 and R7, 1.3 by 1.05 principle. You see, R7, I know that it is 300 ampere because it is 100%. So 1.3 divided by 1.05 of 300 becomes 371.43, which happens to be 37.14% of 1000 ampere. And I have already decided based on rated current 75%. So that is correct, because 37% is less than 75%. I have to go for higher value because relay must not trip for rated current, and therefore my final setting for R6 is 75%, my dear friend. R5 I have to go to now. When I go to R5, you can see that between R5 and R6 there is nothing. Only 1.3 divided by 1.05 principle will work, right? So I find out for R5, my rated current is 721.68, right? And that on 132 kV side happens to be 72.168%. So that way my setting is 75%. But if I consider that 1.3 divided by 1.05 with that transformation ratio 132 by 66, you cannot forget, on 132 kV side current is going to be half 66 by 132. That factor You have to consider, and that takes me to 92.85%, my dear friend. That takes me to 92.85% because the CT at R5 is 500 bar 1. CT at R5, you can see that it is 500 bar 1. Therefore, that setting of R5 takes me to 100%. On this similar line, if you say R4, between R4 and R5, there is nothing, only 1.3 divided by 1.05 principle will work. And therefore, the flux setting of R4 is going to be 125%. PS of R3 is going to depend on 220 kV line current, right? And that is 197 megawatt. So for R3, I have to consider 220 kV line, that is 197 megawatt. That takes me to 71.8%, my dear friend, 71.8%. And if I consider 1.3 divided by 1.05%, that also takes me to 75%. So both way it is correct, right? Therefore, PS of R3 is finally 75% selected is correct. Similarly, PS of R2, I have to consider 1.3 divided by 1.05 principle because between R2 and R3 I have nothing. R2 and R3 only 1.3 divided by 1.05, and no doubt transformation ratio I cannot forget, 132 by 220. So if I consider that, my flux setting of R2 happens to be 100%. And on the same line, PS of R1 is 125%. So my flux settings, my dear friends, are done, and I think you have understood. What all I have done is I have taken care that the rated current I should consider, and 1.3 divided by 1.05, whichever gives me a higher value with reference to flux setting. Next thing what I should do, obviously what I should do, as I told to you, R4 must reach bus E. Now, what is my setting of R4? Let me check up. What is my setting of R4? My setting of R4 is 125%. My setting of R4 is 125%, means for 500 ampere, 125 means it is 625 ampere in primary terms. So 625 ampere is must sense when there is a fault on bus E. Let me check up fault on bus E. Let me check up fault on bus E. Minimum fault current is 2494 and my setting is 625. 100% reaching. No problem. No problem. 100% reaching. So everything checked up. Everything checked up. The flux settings are done. My dear friends, the flux setting are done. I have to go for time setting. When I go for time setting, I have to consider R6, R7 coordination. R6, R7 coordination. I have to find out the time of operation of R7. Add discrimination margin to that. What is discrimination margin? R6 must operate little later. How much later? It should operate 0.25 second later. How did I come to that factor 0.25? While calculating 0.25, I have considered three things. One thing, relay errors. I say that relay R7 will operate within certain time as per formula, but all relays, 100 relays that is manufactured by manufacturer may not operate exactly at that time. There will be some time margin, some time error. You have to allow for certain time discrimination errors, time margins. And as per IS, plus or minus 7.5% beyond PSM4 you have to allow. That is time error of relays you have to allow. R6 may operate earlier, R7 may operate later. You see, that is quite possible. Second thing, R7 operates means fault is not cleared. You have to allow for breaker time. Breaker will take its own time, no doubt. Now SF6 breakers are very good. They operate within 2 cycles, but those 2 cycles you have to consider. And then you have to consider overshoot of relay R6. All these things are very less in static and numerical relays. So you can reduce the time margin between R6 and R7. That is true. And if you use numerical relays and reverse interlocking principle, then you can very nicely reduce the time margin. But right now we do not jump to that. We consider normal relay error, breaker error, overshoot, etc., I consider 0.25 second discrimination margin. That is a discriminatory figure. Many research paper writers are considering 0.2. Some of the research paper writers consider 0.15 also. But I am, you see, considering 0.25 second. So I have to find out time of operation of R7. For what? For the worst fault current. What is the worst fault current? Worst fault current is at bus E for R6 and R7, my dear friend, at bus E, because faulted bus E and just after breaker of R7 does not make much difference, hardly 1 or 2 ampere difference. The faulted bus E is 2400 ampere, fault after breaker is 2399 ampere. You see, it is nothing, negligible, because breaker is hardly 10 meters away. Therefore, I have to consider fault at bus E. My dear friends, fault at bus E, worst fault current 2880, triple line fault. Based on 2880, my dear friend, I am calculating R6, R7 coordination 2880. 300 is my plug setting in primary terms, right? I am considering primary terms only because 1 ampere in secondary means 300 in primary. That means when 300 ampere flows in primary, for 300 bar 1 CT, 1 ampere flows in secondary. That is wrong. It is not so. It's not so. When 300 ampere is flowing in primary, 1 ampere does not flow in secondary. Some 0.03 ampere excitation current is deducted and some less current will flow. But that current is so small that I can forget. That's what I'm doing. I am forgetting that small excitation current. In earth fault relays, I will not be able to forget. But let it apart. अब हम दोनों mix नहीं करेंगे. We won't be mixing two things. 2880 divided by 300. So my plug setting multiplier is 9.6. Time of operation of R7, I am using a mathematical formula 3 upon log PSM into TMS. TMS 0.1 is given to me in data for R7 because I have to give something that I am giving. And therefore 0.3054 second is the time of operation of R7. 0.25 added to that time of operation of R6, I know that it is 0.5554 second. PSM of R6 is 2880. I cannot change the current because I have to compare for same current. My plug setting is 75% of 1000. So that takes me to PSM 3.84 for R6. PSM of R6 3.84. 3 upon log PSM into TMS is equal to time is 0.5554. I know. So TMS is unknown, which I can calculate 0.108. And I cannot set 0.108 because that is not settable. Settable is what? Settable is in multiple of 0.05. I can set 0.05, 0.1, 0.15, 0.2, 0.25. So after 0.108, I set 0.15. So now finally 0.15 is my TMS of R6. Now same method is going to be there. R5, R6 coordination, my dear friend. R5, R6 coordination. R5, R6 also fault current is same at bus E. You can check up. Same 2880. Same 2880. R5, R6 coordination. Same 2880. I am calculating same current. PSM of R6. I have once again found out, which I had already found out 3.84, nothing new. Time of operation is 0.77 because now I know that TMS is 0.15, 3 upon log PSM into TMS. 0.25 added means top of R5 is 1.02. Top of R5 is 1.02. PSM of R5 I have to find out, which is for same current 2.88. I have to consider that 132 by 66 kV transformation ratio. I cannot forget because between R5 and R6 there happens to be a transformer. TMS of R5 therefore is 0.156 and next I will go is 0.2. So TMS of R2 is found out. I mean, you can appreciate that this is the way in which I am going. R6, R7 coordination, R5, R6 coordination, now R4, R5 coordination. For that, I have to consider the current immediately after R4, my dear friend, after R4, that is at bus C. And when I see the fault at bus C, means I have to consider 3240 ampere, and for 3240 R4 R5 coordination, R4 R5 coordination. For 3240 you can check up, sorry, 2146, I'm sorry, 2146 R4 R5 I have to take, right? R4 R5 means after R5, after R5, and after R5 means bus D, and bus D is, I'm sorry, bus D is 2146. I have to consider 2146, which I have considered 2146. I have considered for R4 R5 coordination. You can check up. I have considered 2146 ampere. PSM of R5, this upon plug setting, R5 plug setting, I know in terms of primary I have to find out, right? So that I already know. So 4.292 ampere. That is what is plug setting of R5. Let me check up what is plug setting of R5. Plug setting of R5 is 92.85. That is 100%. And what is the CT ratio? R5 500. So my plug setting is 500 ampere in primary terms. So 2146 divided by 500, if you do, you will get 4.292. You can check up. Very easy. So 500 into 4, 2000. So 4.292 correct. Top of R5, 3 upon log PSM into TMS. TMS R5 already known. TMS of R5 already found out, 0.2. So based on that, I know top of R5 is 0.9483. 0.25 added for top of R4, and based on that I can find out TMS of R4, which is 0.25, which is 0.25. Same fault current. I cannot change the fault current, 2146 ampere. So similarly, when you go to R3, you have to change the fault current, right? Because now when you R2 R3 coordination, you do R2 R3 coordination, then you have to consider fault current after R2 R3 means after R3, that is bus C. So yet same. Bus C means same. Bus C means yet 3240. I'm sorry, not same. 3240. 3240 you have to take. Like that, you have to go on changing the fault current based on what are you coordinating, right? So TMS of R3 is 0.2. TMS of R2 on same line, R1 R2 coordination. Sorry, R2 R3 coordination 0.15. R1 R2 coordination is 0.2. So all TMS found out on same lines, right? And setting of high set unit of R1, the formula is 100 B upon 100 minus A. What is B? B is secondary amperes for the fault. Just, I mean, the line that is covered by that relay. R1 means which line? R1 means which line? Let me check up. R1 means line AB. So what is the meaning of that capital B? Capital B is fault at bus B. Fault at bus B, but in secondary terms. Fault at bus B in secondary term, 3017 ampere. 3017, 3017, my dear friends, you have to take in secondary 1000. So 3017 upon 1000, 3.017 into 100. A is percentage overreach of the relay R1, which is given to be 10%. So I am coming to 3.35 ampere, which is 335% of 1 ampere. But usually the setting range for high set unit is given to be 400 to 2000%. So minimum available itself is 400%. So I will have to set 400. I can't help. So I have to set 400%. So this is how I decide the setting of all relays, my dear friend. You can summarize your final setting. 25%, R1 plug setting, similarly 100, 75, 125, up to R7. TMS for R1, 0.2, 0.15, 0.2, 0.25, you can see. I have finally made a summary of all settings. This is what you have to give to the system person. That you do this setting and go to bed. You can sleep at rest. You need not worry. Now your system will be perfectly protected if you so set the relays. Everything, nothing will be damaged. Everything will be working finely. All relays will work. If one relay does not work, some backup relay will work. Everything is taken care of if you do this, my dear friends. So this is how you can, for a simple radial system, how phase over current relays. Yet we have not talked about the configuration of numerical relays. We have not talked of many things, my dear friend. And if you want to learn everything about power system protection, you have to go to Adapt Me. You have to download from Play Store and you have to subscribe for our 3 of the modules which are available. Slowly more and more number of modules will come and you have to learn. You can learn through mobile app also. But my friends, till then, I will keep on coming to you by this short tutorials to let you know how simply you can calculate relay settings, etc. Right? Thank you till then. Good day, everybody.